Alright, here's your Chapter 3A review. Essentially, this whole chapter is about solving systems, and there are three ways in which you can solve a system. The first way is graphing. Okay, so I'm going to look at a couple of questions. Probably I'll let you look at one and let you work on the other, where you solve a system by graphing. The other two ways are substitution and elimination. Alright, for the tips you see to the right here, it says the solution to a system is the point of intersection, xy, between two lines. And this is something that is often forgotten by students. They kind of forget when you're solving a system, what you're finding is the point, the xy coordinate, where the two lines actually intersect. So when I graph it, I kind of visually see that intersection point, and that's going to help me to kind of really understand what a system solution is. The other ways, substitution and elimination, are algebraic ways, but essentially I'm still doing the same thing. I'm finding the point of intersection between two lines. So we're going to look at one graphing and one substitution on this page, so just get going with it. Let's see how this goes. Okay, we're going to look at number 2. I'm going to graph these two lines. Okay, in order to graph lines, how do you need your equations to look? Yes, slope-intercept form. You have to make sure that they are in y equals form. Well, the first equation, luckily for us, is in that form. I don't have to change that one at all, so I'm going to graph that equation just as it looks. The second equation, 8x minus 4y equals 4, has to be worked with. I have to subtract the 8x. Alright, I'm going to divide by -4. And I'm going to get y equals 2x minus 1. Alright, cool. So, what you see here. Already, being a math teacher, I kind of see what's going on here. I got two equations. I'm going to rewrite them closer to the graph so I can see it when I'm graphing. So y equals 2x plus 3. And then y equals 2x minus 1. So from here, I'm just going to graph these and see what happens. But I kind of already know, based off the fact that I'm a math teacher, that I know that these graphs are probably going to be parallel. And I know that because they have the same slope. And when graphs are parallel, if they have the same slope, they usually intersect in one of two ways. Okay, they're either going to be parallel, where they never touch, or they're going to be the same exact line, where they're always touching. If they are always touching, then this system has an infinite number of solutions. Okay, similar to when we solved the equations and the x's canceled. It's kind of what's going to happen here. So for this particular problem, I'm going to graph both lines. I got a slope of 2, so up 2 over 1. And you see that that's a line. That's the line y equals 2x plus 3. And then I got an equation y equals 2x minus 1. I go up 2 over 1, up 2 over 1, and I see that this is the line y equals 2x minus 1. And you see what's going to happen here. If you're trying to find the intersection point, these don't intersect. Okay, these are parallel. Okay, when lines are parallel, they have the system has no solution. Okay, something to watch out for. So for these particular ones, the lines end up being parallel. In this case, there is no solution to this particular system. So looking at that particular equation, hopefully that makes a little bit of sense. The last problems I want to go over are substitution. Okay, both of these questions lend themselves for substitution because there are variables that are singular. Okay, what I mean by that is some variables in here have no coefficients. Okay, they're just sitting there by themselves. When that happens, you know that you can do substitution. So whether you like substitution or elimination, it's a matter of preference, but you need to know how to do both. So I'm going to solve this first equation for x. So x equals 4y plus 7. Okay? So what I see there, that's my first step. I solve for one variable. And then I take and I plug it in for x in the other equation. So my other equation becomes 2 times what I just solved for x, which is 4y plus 7. Plus y equals 5. So you can see what I just did is that this x just basically got replaced with 4y plus 7. It's because x equals 4y plus 7. So that's a substitution. It's a very simple step, but if you're more familiar with elimination, this might be a little bit more foreign to you. So but from here, it's just like solving any other simple equation like we did in chapter 1. So it's 8y plus 14 plus y equals 5. I'm going to combine like terms. I get 9y plus 14 equals 5. I'm going to subtract 14. 5 minus 14 is -9. So then I get y equals -1. Alright, so again, it's a system. Systems have two solutions. So then I take my, I could actually plug it in here, and now that I know y equals -1, I'm going to say plug it in for y. So again, all I did here was take y, and I just plugged in -1. So continuing on, I get -1 plus 7, so x equals -4 plus 7, or x equals 3. So now I see that x is 3, y is -1, so the point of intersection, don't forget what you actually just found, is the intersection point, is 3, -1. So hopefully this helps, and you'll be able to do substitution very easily. And again, if you have a situation like this, like I said, where you have singular variables with no coefficients, substitution actually is a little bit easier, I think, than elimination in a lot of cases. So, all right, page 2 of your chapter 3A review gets a little bit into elimination, method of solving a system. It also gets into graphing systems of inequalities, and then your system word problems, which we'll talk about on the next page. Essentially here, you see the tips on the right side say elimination. Elimination is a process by which you multiply one or both equations by a number in order to allow one variable to cancel or be eliminated when you add the equations together. So this process is one that's I find that most students like. Some students do tend to drift towards substitution, but a lot of more students, I say majority, like elimination better. Substitution, once again, is solve one equation for one variable and then plug it into the other equation, which we just did in the previous page video. So looking here, let's start off by, let's look at question 6 right here. And it says solve by elimination. So I'm looking here and I'm saying, okay, I gotta multiply one or both equations by some number that's gonna allow me to cancel the variables. And just looking at this one, they're both equal to 0. So it's kind of looks like no matter what I do, I'm going to get one of the variables equals 0. So we could do a couple things here. I'm kind of looking at the y values, and I'm looking at those. Okay, you don't always have to just look at the front terms. I'm looking at the y values, and I'm saying, okay, 9y and -3y. I don't have to multiply both equations. If I just multiply this bottom equation by 3, it's going to see, I'm going to get -9 for my second equation, and I'll be able to cancel out the y's. So that's what I'm going to do. So my new system, the top equation doesn't change, but my bottom equation gets distributed. This 3 gets distributed to everything. Okay, 3 times 4x is 12x, 3 times -3 is -9, and 3 times 0 is 0. Okay, at this point you add the equation straight down. If I did things correctly, one of my variables will cancel. So this gives me 17x equals 0. So then x ends up equaling 0. So I can see how that works. X ends up equaling 0, and it's not it's not no solution in this case, because basically if you divide 0 by 17, you do get 0. Okay, a lot of times students see that it equals 0. You're like, no solution. Well, it works. 0 is an answer. So x equals 0. So now I take 0 and I plug it in. So 5x plus 9y equals 0, and it looks like I'm probably just going to get y equals 0 too, but I just wanted to walk through the substitution process. Again, x value and y value, so this becomes 5 times 0 plus 9y, so then I get 9y equals 0, and then divide by 9, again y equals 0. So the point of intersection of these two lines is 0, 0. So that would be how you do question 6. Alright, moving on, I want to talk about number 8, and then we'll talk about the word problems on the next page. So it says graph the following system of inequalities. Once again, I'm graphing lines. How do you graph lines? Very similar to when we tried to solve a system by graphing just equations. I'm going to do the exact same thing. So in order to find this one, first thing I got to solve or do is solve for y for both equations. So I'm going to rewrite these equations down here, alright, next to each other, so that I can see exactly what it is I'm trying to do. So I got 3x minus 2y is less than 1, and I got x plus 3y is greater than or equal to 5. So I'm going to solve these equations. I'm going to subtract 3x from both sides. I get -2y is less than -3x plus 1. I'm going to, well, I'll just keep going with this equation. I'm going to divide by -2. We have to remember what happens now. Okay, what happens when you divide by a negative when you're working with inequalities is these signs flip. So instead of y being less, y is greater. -3 over -2 is +3 over 2. and then positive 1 over negative 2 is negative 1/2. Okay, so there's one equation. It's not a pretty equation, but it'll work. The next equation, I gotta do. So in order to do that, I subtract x from both sides. So I get 3y is greater than or equal to negative x plus 5, divide by 3. So I get y is greater than or equal to negative 1/3 x. When you divide x with no coefficient by 3, you gotta imagine there being a 1 there. So that's something students sometimes trip up on, but just understand it's gonna be negative 1/3 is my slope, and then it's plus 5/3. So from here, I go over to my graph. Alright, and I want to graph both of these equations. So in order to know what they are, I'm going to write them pretty close to the graph so that's a little bit easier to see. So my two equations are y is greater than 3/2 x minus 1/2. And my other equation is y is greater than or equal to negative 1/3 x plus 5/3. Is greater than or equal to negative 1/3 x plus 5/3. Alright, so I graph these, like I said, just like any old equation. It's just my solution is going to be the intersection of their shading. So just like when we graphed the inequalities in the last chapter, I think about, is the line solid or is the line dotted? And the next thing I think about is, what side do I shade on? So I'm going to graph these, and the graphs aren't going to be perfect because you got fraction y-intercepts, but we'll do our best. So I'm going to take negative 1/2, and I'm going to go up 3 over 2. Okay, so it's a positive slope. And y is greater than, so the line for this is going to be a dotted line. So there's my equation for this particular one. I'm going to graph the other equation. I'll use a different color. And this one has a y-intercept of 5/3, which is 1 2/3. So it's a little bit up. And again, we're going to try to be as accurate as we can. It's not going to be perfect though. So 5/3, and it's a slope of negative 1/3. So what I always go up, but in this case, since it's negative, I'm going to go left 3. So I'm going to go up 1 to the left 3. So rise 1, run 3, but in this case, run 3 to the left. And my line for this particular one is going to be solid. Okay. So I figured out the equations of the lines. I haven't shaded yet. So for shading, I got to make sure that I shade on the correct side. So for my dotted line, y was greater. So in that case, since y is greater, I shade above. Okay. For the other case, y was greater as well. So again, I shade above. So you see what the solution looks like is this area here. Okay. So when you graph a system of inequalities, my solution is the graph. It's this part right here. It's this section that is shaded by both inequalities. Alright, we're going to look at one word problem here, and my major tip here is a lot of these system word problems deal with money. So when you have a situation where you have some equation involving people or tickets or whatever, and then there's another equation involving money, keep the money with the money. Okay, so that's going to be one way to figure out what your two equations are going to be. Because the hardest part about solving a word problem that involves a system is coming up with the two equations. Because after you come up with the two equations, it's simply a matter of just solving the system. So figuring this out, I'm going to look at question 11 here. And we're going to take a look and see how to solve this one. So this is one Friday night at Chapel's Chop House. 138 dinners were sold, consisting of filet mignon and pork chops. If the filet mignon cost 32 and the pork chops cost 28, and the total money collected was 41.20, find the number of each dinner sold, write both equations, and solve the system. Okay, so here's an example where I was saying you got a money equation. You got an amount of money that was taken in, and you got an amount of money for each of the dinners. So I'm gonna call pork chops P and filet mignons F. So I got two variables in this particular system. So F equals the number of fillets sold. Okay, that's a really good looking L, but I'm going to keep it. And then I got P representing the number of pork chops. Okay, so what you have here is a total number of 138 dinners sold. So you got a set number of fillets sold and a set number of pork chops sold, and altogether there are 138 dinners. So my first equation is actually easy. It has nothing to do with money. It just has it has to do with the number of total dinners sold. So my first equation should be the easiest part, which is F plus P equals 138. Okay? So like I said, keep the money with the money and keep the other parts with the other parts. And most of the problems can be solved in this manner. Some of them are a little bit tricky, but this is one where I think that you can kind of follow that rule. So now I got a money equation. So every fillet that I sell costs $32. Every pork chop dinner I sell costs $28. So you got $32 times the number of fillet dinners sold plus $28 times the number of pork chop dinners sold. And the total amount of money you took in was $41.20. So there's your money equation. Like I said, keep the money with the money. Alright, now all that's left is to solve this equation. I could solve it by substitution or elimination. I'm going to choose substitution because I see two singular variables with f and p in the first equation. So very simply, I can solve the first equation for p and say p equals 138 minus f. Okay? So what that means is now I see, well, if p equals 138 minus f, I can just replace p in the second equation with 138 minus f. So I'm left solving this equation, and this is where your calculator will come in handy. I distribute the 28. I get 32f plus 28 times 138 gives me 3864 minus 28 times f, which is just 28f, negative 28f, equals 4120. Okay? At this point I combine my like terms. I get 4f plus 3864 equals 4120, and I subtract 3864. Alright, so I get 4f equals 4120 minus 3864, giving me 256. So 256 divided by 4 gives me 64. So what that just tells me is that f equals 64. So there were 64 filet mignon dinners. So the next question is how many pork chop dinners, which is pretty easy to determine considering there were 138 total dinners. Out of the 138, 64 were fillets. So 138 minus 64 gives me the number of pork chop dinners, which in this case is 74. So once again, pork chop dinner 74, fillets 64. The hardest part about this question, once again, is setting up the equations. Take your time with that part, okay? I don't know about your teacher, but I know as a teacher, that's where I give most of the points, is because I know students can pretty much solve a system for the most part. You know, if they had a system in front of them, solving isn't the most difficult part. That's why these word problems are different. Clearly, you have to set them up. That's where you get most of your points for these questions. So take your time with the setup. Make sure each equation makes sense. So hopefully this helps and you do well on your test.